Hello, friends. Today we come up with an episode on S block elements. S block elements are very important chapter in class 11th chemistry. Elements in which valence or outermost electrons enters in the s orbital are called s block elements. S block elements are placed to the left hand side of long form of periodic table. S orbital can accommodate a maximum of 2 electrons. S block contains two groups, vertical columns in periodic table, namely group 1 and group 2. Elements of group 1 are called alkali metals and those of group 2 are called alkaline earth metals. Occurrence of S block elements. S block elements do not occur in nature in free state. Among the alkali metals, sodium and potassium are abundant and lithium, radium and cesium have lower abundance. Among the alkaline earth metals, magnesium and calcium are abundant in earth crust. Radium is rarest of all. Group 1 elements, that is alkali metals. General electronic configuration of group 1 elements is NS1. All alkali metals have one valence electron, hence form monovalent M plus ion and are highly reactive. Group 1 consists of following elements: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. The electronic configuration of group 1 elements is as hydrogen having symbol H, atomic number 1, have electronic configuration as 1s1, while lithium having symbol Li, atomic number 3, have configuration He2s1, means configuration of He and 2s1. Sodium Na11, Ne3s1. Potassium having symbol K, atomic number 19, electronic configuration in condensed form as for sodium Ne3s1 and for potassium Ar4s1, and for rubidium Kr5s1, for cesium Xe6s1, for francium Rn7s1. Dear friends, you can also visit our website www.chemistrynotesinfo.com to download PDF notes of this chapter, or you can alternatively join our Telegram channel to download all chemistry notes. Anomalous behavior or properties of lithium. Amongst alkali metals, lithium has smallest size and highest polarizing power, that is charge to radius ratio. Due to this reason, lithium behave different from other elements of group 1 alkali metals. It shows following anomalous properties. Lithium is hard metal. Its melting point and boiling point are highest among the group. Lithium is least reactive amongst all alkali metals, and it is the strongest reducing agent. Lithium hydride is the stable amongst all the alkali metal hydrides. LiOH is weak base, while hydroxides of other alkali metals behave as strong base. Lithium nitrate when heated gives lithium monoxide LiO, while other alkali metals nitrate decompose to give corresponding nitrites. Lithium combines with ammonia to form lithium amide Li2NH, while other alkali metals form amides of the general formula MnH2, where M is equal to NaKRbCs. Diagonal relationship of lithium with magnesium. The element lithium of second row shows similar properties with its diagonally opposite member magnesium of third row. This is known as diagonal relationship. The diagonal relationship is due to the similarities in ionic size and polarizing power, that is, charge to radius ratio of lithium and magnesium. Also, electronegativity of lithium is 1.0 and magnesium is 1.20 are not much different. Periodic trends of alkali metals. Atomic and ionic radius of S block elements. Alkali metals have the largest atomic and ionic radius in their respective periods. On moving down the group, the size goes on increasing due to the presence of extra cells. Hence, the atomic and ionic radius also increases down the group. Ionization enthalpy and or energy of S block elements. Ionization enthalpies of alkali metals are low and decreases down the group from Li to Cs. This is due to increase in atomic number, size and nuclear charge and increase in screening effect. Electronegativity of S block elements. Electronegativity of the alkali metals is very low due to their electropositive character. The electronegativity decreases from Li to Cs as the electropositive character increases. Melting and boiling point of S block elements. Alkali metals have very low melting and boiling points due to presence of weak intermetallic bonds. It decreases on moving down the group. Oxidation states of S block elements. Due to the presence of only one electron in the valence shell, they exhibit only +1 oxidation state. S block elements chemical reactivity. The alkali metals are highly reactive due to their large size and low ionization enthalpy. Reactions of S block elements with oxygen or air. Alkali metals burn vigorously in oxygen to form oxides. Lithium forms monoxide LiO and sodium forms peroxide LiNa2O2. 4Li plus O2 gives 2Li2O oxide. 2Na plus O2 gives Na2O2 peroxide. The other elements form superoxides. M plus O2 gives MO2 superoxide, where M is equal to KRbCs, means potassium rubidium cesium. Reaction of S block elements with water. The alkali metals react with water to form corresponding hydroxides and evolve hydrogen gas or dihydrogen. 2m plus 2H2O gives 2MOH plus H2, where M is equal to LiNaKRbCs, means alkali metals. Reactions of alkali metals with hydrogen or dihydrogen. Alkali metals react with dry hydrogen or hydrogen at high temperature 673 Kelvin to form corresponding hydrides. 2m plus H2 gives 2MH. Alkali metals reaction with halogens. All alkali metals react vigorously with halogens to form their respective ionic crystalline halides with general formula Mx, where M is equal to Na K RbCs and X is equal to Cl Bri and F. 2m plus X2 gives 2mx. Some important compounds of sodium. First is sodium carbonate, washing soda, Na2CO3. Sodium carbonate is usually prepared by a process known as ammonia soda process or solvay process. I repeat, sodium bicarbonate, sorry, sodium carbonate is usually prepared by a process known as ammonia soda process or solvay process. Raw materials are NaCl, NH3 and limestone for CO2. The process involves the following steps. Step first, CO2 gas bubbled through a solution of NH3 to form NH4HCO3, that is ammonium hydrogen carbonate. NH3 plus H2O plus CO2 gives NH4HCO3. Step second, sodium hydrogen carbonate, that is NaHCO3, precipitates out because of common ion effect caused due to the presence of excess NaCl. So NH4HCO3 plus NaCl gives NaHCO3 plus NH4Cl. Step third, the precipitate NaHCO3 is then filtered off and ignited to get sodium carbonate Na2CO3. So 2NaHCO3 on heating gives Na2CO3 plus CO2 plus H2O. Properties of Na2CO3. Sodium carbonate crystallizes from water as a decahydrate. Sodium carbonate decahydrate. Na2CO3 dot 10H2O, also known as washing soda. Above 373 Kelvin, the monohydrate from becomes completely anhydrous and changed to a white powder called soda ash, that is Na2CO3 dot H2O. Above 373 Kelvin gives Na2CO3 plus H2O. Uses of Na2CO3. It is used in the manufacture of glass, soap, borax and caustic soda. It is used in water softening in laundry and cleaning. It is used in paper, paints and textile industries. Sodium hydroxide, caustic soda, NaOH. Commercially, sodium hydroxide is prepared by the electrolysis of sodium chloride in Costner-Kellner cell. It is also prepared by adding calcium hydroxide to the solution of sodium carbonate, that is Na2CO3 plus CaOH2 gives 2NaOH plus CaCO3. Properties of NaOH. Sodium hydroxide is a deliquescent white crystalline solid. It is readily soluble in water and forms a strong alkaline solution. The solution of sodium hydroxide at the surface react with CO2 in the atmosphere to form Na2CO3, that is 2NaOH plus CO2 gives Na2CO3 plus H2O. Uses of NaOH. It is useful in purification of bauxite and to manufacture of soap, paper, artificial silk and a number of chemicals. It is useful in petroleum refining and textile industries. It is important as laboratory reagent and in preparation of pure fats and oils. Sodium chloride NaCl. It is also known as common salt or table salt. It is mainly obtained by evaporation of seawater. Crude sodium chloride thus contains CaSO4, CaCl2, MgCl2 as impurities and is deliquescent. Pure NaCl is obtained by passing HCl gas through saturated solution of crude NaCl. Due to common ion effect, NaCl gets precipitated. Properties of sodium chloride NaCl. It is white crystalline solid. It has melting point of 1081 Kelvin and boiling point of 1713 Kelvin. It has solubility of 36 gram per 100 gram of water at 273 Kelvin. NaCl when heated with concentrated H2SO4 and MnO2, it liberates chlorine gas. So 2NaCl plus MnO2 plus 2H2SO4 gives MnSO4 plus Na2SO4 plus 2H2O plus Cl2 gas. Uses of sodium chloride NaCl. It is used as a common salt or table salt for domestic purpose and preservative for meat, fish, etc. It is used for the preparation of Na2O2, NaOH, Na2CO3, etc. Sodium hydrogen carbonate NaHCO3. It is also known as sodium bicarbonate and baking soda. It is made by saturating a solution of sodium carbonate with CO2. So Na2CO3 plus H2O plus CO2 gives 2NaHCO3. Properties of sodium hydrogen carbonate NaHCO3. It is white crystalline solid sparingly soluble in water. On heating, it gives Na2CO3 and CO2, that is 2NaHCO3. On heating at 373 Kelvin gives Na2CO3 plus CO2 plus H2O. Its aqueous solution is alkaline due to hydrolysis. So NaHCO3 plus H2O gives NaOH plus H2CO3. I repeat, NaHCO3 plus H2O gives NaOH plus H2CO3. Uses of sodium hydrogen carbonate NaHCO3. It is used in fire extinguisher and for baking of cakes, breads, etc. It is also used as medicine to minimize the acidity of stomach, that is antacid. Biological importance of sodium and potassium. Sodium and potassium are very important and play a vital role in biological system. Our bodies obtain them from fruits and vegetables. Common salt is the most important source of sodium in the diet. These ions maintain the sensitivity of nervous and control muscles, nerves and control muscles. Deficiency of sodium shows reduction in fat deposit, atrophy, lung infection, retarded bones growth, reduced blood pressure, etc. Deficiency of potassium reduces heartbeat, hypertrophy of kidneys, paralysis of muscles. Now we are going to discuss group 2 elements, that is alkaline earth metals. The general electronic configuration of group 2 elements is NS2. All alkaline earth metals have two valence electrons, hence form divalent M2 plus ions and are highly reactive like alkaline metals. Group 2 consist of following elements, that is beryllium, magnesium, calcium, strontium, barium, radium. Electronic configuration of group 2 elements is as beryllium has electronic configuration of He2s2, that is configuration of helium and 2s2 extra. Magnesium Ne3s2, calcium Ar4s2, strontium Kr5s2, barium Xe6s2, radium Rn7s2. Dear friends, you can visit our Telegram channel, that is @chemistry notes info, to download PDF notes of this chapter. Anomalous properties of beryllium. Beryllium, the first member of group 2 metals, shows anomalous properties as compared to magnesium and rest of the member of group 2. It is due to its small size and highest polarizing power. It shows following anomalous properties. Beryllium is hard metal while other alkaline earth metals are soft. The melting boiling points and ionization enthalpy of beryllium are highest of all the alkaline earth metals. Beryllium forms covalent compounds while all other members form ionic compound. Beryllium does not liberate H2 from acids while other metals liberate H2. Diagonal relationship between beryllium and aluminium. The element beryllium is the first member of group 2 which shows similar properties with its diagonal opposite element aluminium of group 13. This diagonal relationship is due to similarities in ionic size and polarizing power. Periodic trends of alkaline earth metals. Atomic and ionic radius. Atomic and ionic radius of the alkaline earth metals or alkaline earth elements are smaller than those of corresponding alkaline metals of the same period. The atomic and ionic radius increases down the group with increase in atomic number. Ionization enthalpy or energy. Ionization enthalpy of alkaline earth metals are higher than those of alkali metals. Ionization enthalpy decreases down the group. Electronegativity. Electronegativity of group 2 elements decreases down the group. Their electronegativity values are higher than those of alkali metals. Melting and boiling point. Melting and boiling point are not regular in the group, mainly due to different crystal structure of the metals. However, these are higher than those of alkali metals. Oxidation states. Due to the presence of only 2 electrons in the valence shell, they exhibit only +2 oxidation state. Chemical reactivity. Due to low ionization enthalpy, alkaline earth metals are fairly reactive. However, their chemical reactivity is lower than those of alkali metals. Reaction with oxygen. With pure oxygen, beryllium, magnesium and calcium form oxides, whereas beryllium, strontium and barium, strontium and radium form peroxides. That is 2M plus O2 on heating gives 2MO, where M is BeMgCa. That is metal oxides are formed 2MO, and M plus O2 on heating gives MO2, that's metal peroxide, where M is BaSr and Ra. The affinity of metals towards oxygen increases down the group. Reaction with water. Alkaline earth metals react with water to form metal hydroxide and evolve hydrogen gas. The chemical reactivity with water increases from magnesium to barium. M plus 2H2O gives MOH2 plus hydrogen gas, where M is equal to MgCaSr or Ba. Reactions with hydrogen. Except beryllium, all the alkaline earth metals react with hydrogen on heating to form metal hydrides of the general formula MH2. So M plus H2 on heating gives MH2, where M is equal to MgCaSrBa. Reaction with halogens. All the alkaline earth metals react with halogens at high temperature to form their halides. M plus X2 gives MX2, where X is equal to FClBrI, means halogens. F for fluorine, Cl for chlorine, Br for bromine, I for iodine. Important compound of calcium. Calcium oxide or quicklime, CaO. It is prepared commercially by heating limestone CaCO3 in a reverberatory kiln at 1070 to 1270 Kelvin. So CaCO3 on heating gives CaO plus CO2 gas. Property of calcium oxide or quicklime CaO. Calcium oxide is a white amorphous solid. It has a melting point of 2870 Kelvin. When it is exposed at atmosphere, it absorbs moisture and carbon dioxide. So CaO plus H2O gives CaOH2 and CaO plus CO2 gives CaCO3. Uses of calcium oxide or quicklime CaO. It is used in the manufacture of sodium carbonate from caustic soda. It is an important primary material for large scale production of cement. Calcium carbonate CaCO3. Calcium carbonates occur in nature in several forms like chalk, limestone, marble, slate, calcite, etc. It is prepared by passing carbon dioxide through slacked lime. So CaOH2 plus CO2 gives CaCO3 plus H2O. It can also be prepared by adding sodium carbonate to calcium chloride, that is CaCl2 plus Na2CO3 gives CaCO3 plus 2NaCl. Properties of calcium carbonate CaCO3. It is white fluffy powder. It is almost insoluble in water. When CaCO3 is heated to 1200 Kelvin, it decomposes to evolve CO2. So CaCO3 at 1200 Kelvin gives CaO plus CO2. It reacts with dilute acid to liberate carbon dioxide. So CaCO3 plus H2SO4 gives CaSO4 plus H2O plus CO2. Uses of calcium carbonate. It is used in the manufacture of quicklime and in building material in the form of marble. It is used as antacid, mild abrasive of toothpaste, constituents of chewing gum.
You all enjoy chewing gum? If yes, then you enjoy calcium carbonate also. Calcium hydroxide or slacked lime CaOH2. It is prepared by adding water to quicklime. CaO plus 2H2O gives CaOH2 plus H2 gas, means hydrogen gas. It is also prepared by treating calcium chloride with caustic soda, that is CaCl2 plus 2NaOH gives CaOH2 plus 2NaCl. Properties of calcium carbonate CaCO3. It is white amorphous powder, sparingly soluble in water, and aqueous solution is called lime water. When CO2 is passed through lime water, it turns milky. CaOH2 plus CO2 gives CaCO3 plus H2O. The milkiness disappears on passing CO2 gas in excess because CaCO3 plus CO2 plus H2O gives CaHCO3 2. Uses of calcium carbonate CaCO3. Calcium carbonate CaCO3 is used to prepare mortar, which is an important building material. It is used in glass and tanning industry. Also used to prepare bleaching powder and for purification of sugar. Dear friends, I think you enjoy listening this important chapter on S block of elements. If you enjoy, please share this chapter with your friends and colleagues. Thank you to listening this episode. This episode is brought to you by www.chemistrynotesinfo.com.